Hi, this short video will show you how easy it is to use MULTOS TrustCore to secure IoT devices that are connecting to Microsoft's Azure IoT Hub. In case you don't already know about MULTOS TrustCore, in a nutshell, it is a small hardware security module that you can build into your IoT devices. See our introductory videos on YouTube for more info. Azure IoT Hub offers three types of device authentication. SAS tokens are based on symmetric keys which need to be securely shared between the IoT hub and the devices. Third-party services exist to assist with this tricky task. TPMs are irrelevant to us. If you want to use this halfway house solution, then you wouldn't be using a MULTOS-based device anyway. And finally, X509-based PKI is the most secure and flexible method recommended by Microsoft. MULTOS TrustCore can do much more than authenticate. It can perform all the crypto for the TLS handshake and subsequent encryption. This makes it super secure and removes the need for the IoT device to have crypto support in its software. Let's look at what SAS tokens are. Despite the buzzwords, this is nothing fancy. A device puts together a string in a particular format, requesting a connection or service for a length of time, and signs that string using a keyed MAC algorithm called HMAC SHA-256. This is to prove it is a genuine request from a genuine device. Without an HSM like TrustCore, the key has to be stored in the device's software, so is vulnerable to being extracted, and therefore devices can be cloned. The demos are built to run on a Raspberry Pi. The Python version of the Azure IoT SDK is used, with one small modification. The key in the connection string now refers to the slot to use in the TrustCore key storage. The SDK modification calls TrustCore to do the signing rather than doing it in software. This means the key never needs to leave the secure environment. In this code snippet, you can see the modified connection string. So, onto the first demo. Here we have two windows at the top, which are terminals on the Raspberry Pi. The right one will display the low-level traffic between the Pi and TrustCore. Under those, we can see the Azure portal and device listed in the Azure IoT Hub. The primary key value is the one stored in TrustCore. The Cloud Shell will allow us to monitor the messages being sent from the device to the endpoint in the hub. First, I'll check the contents of the TrustCore symmetric key store. Then, when I run the sample script, you will see the calls being made to TrustCore on the right. That is, a simple call to sign the token. Now let's look at the X509 option. This is a classic mutual authentication setup. The hub trusts the device because the device can prove it has a certificate signed by a trusted party, and vice versa. The code for the X509 sample app is changed slightly to initialize TrustCore. Also note that the key file provided is now a dummy one. This is not the actual private key. That was generated by and is locked away inside TrustCore. A few more modifications to the SDK would remove the need for this dummy. TrustCore is used for more than just the signing operations with Azure. It does all the crypto for the whole TLS handshake and subsequent message encryption and decryption. This is thanks to Azure making use of OpenSSL, for which we already have an integration with TrustCore. And don't forget, as well as supporting the Azure authentication, your device can make use of TrustCore for other purposes, such as encrypting stored data or securely storing other device information. The possible uses are endless. You can even write your own MULTOS apps to run alongside TrustCore. The X509 demo setup is the same as for the SAS token demo. In the left-hand terminal window, you will see extra messages from our modified OpenSSL library, showing when MULTOS TrustCore is being used. Thanks very much for watching. I hope you found this interesting and look forward to hearing from you if you'd like to know more.